Morning, so we can hear you.
Right. Okay, good to see at least a few of you up and early. I guess you have had a whole week of lectures. But it's my first lecture. Okay, so as I said, today we are going to look at the final topic, and that is machine learning outside your own computer. Right. So there has to be a use case. I mean, obviously, if there's no use case, then there's no need to do it, right? So I want to find out, some of you may have kind of hit that use case during your project, right? So I want to get some ideas from you. Why do we need this? You can just unmute and say, why do we need to do this? And of course, in the context of this course, it is business analytics. Why would you need to do business analytics outside your own machine? I think you have already done some BI stuff using BI Studio. What is it called? Power BI, right? Power BI, right? I assume you implemented it on your computer. Can someone say whether you implemented it on your computer or in the cloud? Your Power BI sessions? You may have to call out names. Who's here? Lahiro, did you do this, your Power BI sessions on your own computer or in the Microsoft?
We have done it in Microsoft servers, I think. On as practicals, we did on our local machines. We got the access from the instructor. Yes, gave the.
Right. Okay. Right. Yeah, I think Microsoft is also moving things more and more into the cloud. So if you want to do analytics, I think you have to use Azure ML, right? Am I right? So for the BI part, you can do it actually on your own machine. You can download Power BI onto your machine and do it on your machine. But if you want to do analytics, I think while it could be done, they have kind of moved that onto their Azure platform. Right. So why is that, and what is the use case for doing analytics in the cloud? Can you give some answers? I mean, there's no single answer, but we can together come up with some answers.
So because we can do these analytics as a team if we are doing it using a cloud compared to when we are using our own personal computer.
Okay, good. That's not the normal answer people would give, but it's a very good answer because, of course, some of you are in teams doing your final year project, so you would have found that itself is worth it, right? That itself is really, really important. Any other?
Because ML requires a lot of resources in terms of hardware and all, and it might be difficult to source them in-house.
Okay, good. So resources, compute resources. So a lot of people, and I think this is important as IS, I mean, people who are graduating with a technology degree, that a lot of people uh, they don't, let's say, they don't think about, when they talk about resources, they talk about hard disk space, right? And it turns out that on your own computer, you can handle massive uh, data, right? Even on your own computer. But when you talk about resources, it's more than just the hard disk. So when people talk about hosting or whatever, they usually talk about content. And initially it was all static content, but now it's obviously dynamic, with some back-end processing and all that. But this brings another dimension, and that is the compute cloud, right? A lot of people it's in the cloud. This is, my email is in the cloud. Those things are generally about storage, right? But when you're into analytics, you need a compute cloud. That means you need CPUs, and you need GPUs, and you need TPUs and things like that. So there is an advantage, or sometimes not an advantage, sometimes just a necessity. But one advantage is that, a simple advantage is that you free your computer, right? You don't want to tie up your computer in some complicated task when you have other work, right? You may have to write letters, emails, you have to, check up other things and so on. And if your machine is completely tied up with some processing, that's going to be really hard. So just to free up your computer itself is already something you need. But going beyond that, yes, it could be storage. If you want to kind of store lots and lots of intermediate models, right? Then quickly you find that your space is running out. Then CPU, yeah. So if you have multiple, you may have 4 cores, but maybe a cloud service can give you more cores. And then memory, maybe you have, 4, 8, or 16 GB, but you can get more. And then a critical thing is GPU, because some libraries have been optimized for using GPUs, such as TensorFlow, for instance. And that greatly speeds up processing. And generally on your own laptop, it's unlikely, unless you have a compatible GPU, it's unlikely that your GPU will do that stuff. Right? And then you have the cluster, right? So when it's really hard to talk about what is big data, right? So people say, oh no, this, my data set has 17 million records. 17 million records will easily fit into your laptop, right? So that's not the thing, right? So however big your data set is not really the thing, right? The thing is that many algorithms require the data to be in the memory, right? So memory is, of course, fairly critical, right? And so when your application exhausts your memory that is available to you, then you want to go to the cloud, because in the cloud you may be able to run a cluster, right? And now this is a bit specialized, and we are not going into this, but a platform like Spark or MapReduce, Hadoop, right? They provide you a way to distribute the data and make the algorithms work on those distributed data, and then to bring the results together, right? So there are lots of these kinds of benefits. One benefit that probably you will figure out when you go into the industry, right? Or some of you may have experienced it while being on internship, is the convenience, right? So as students, you love to kind of, DIY, do it yourself, right? And mess around and so on. But when you go to the industry, they don't want you to mess around. They want to ease of you. So how do you do these things uh, in a kind of a workflow or a pipeline? And so the tools used for the first half, which is RapidMiner or Orange or any of those tools, Weka, they provide those initial idea of pipelining. Right? So you build a workflow or a pipeline, and then you can reuse it, right, by changing the data. Let me save some bandwidth. Right. So, right. So I want to break this session. As I have promised, I won't go over 90 minutes. So the first part into just giving some of the ideas and the concepts, and then starting you off on the hands-on, right? I know a lot of you are now at the stage of your projects that you have less time for coursework, but I am assuming that some of these things will be useful to some of you as you go into the industry. So, so we will start you. I will start you off on the hands-on for this week. But as I promised earlier, I will not give any more assignments. Okay, so these are like the dominant cloud platforms for compute and for AI or machine learning, right? This is the grandfather, Amazon Web Services, right? And then Microsoft Azure, which is Microsoft's cloud platform, and Azure ML is where you would do analytics. For Amazon, I'm not going to talk too much about this because this is the example I'm going to take today. Google Cloud Platform has something called Vertex AI, which kind of brings together a lot of their machine learning tools, right? And some of you may have used their Colab, which is probably the only free forever kind of offering, right? Even among all these, right? Except that there are some restrictions about how long it runs and things like that. And the IBM Cloud, where you have the ML is embedded in this, or the AI is embedded in Watson Studio. Actually, these people also have various studio versions, right? But looks like they're moving away from the studio thing, because the studio thing was actually something you could download and run on your machine. But now those things are becoming, I think there was something called Azure ML Studio, I think, which they're kind of phasing out, and now you've got to do it in the cloud. There are others, so it may be good for you to try and figure out, do a Google search and ask people. I know a lot of people who were doing projects that required cloud compute. They were looking for that, ideal free forever kind of thing. And finally, they came and asked, can we use our in-house platform? So in-house, we have something called the Ant PC, which of course doesn't provide cloud services. It just provides you the GPU, access to GPU, and I think some number of cores of CPU. Right. So this comparison, of course, there's no comparison that is completely independent, right? This is by some company called Alltechsoft. I linked it here because this is a cloud ML, but they also talk about cloud image processing, cloud vision, video processing, cloud text processing, and so on. Different services. And you can see that all the platforms provide classification and regression, and that's basically the most important thing we're looking at. Clustering, it says that Watson doesn't provide, but I'm not quite sure about that. And then these other things, right? For instance, labeling, right, has become more and more important, annotation. And so most of these platforms now provide labeling services. This is, I think you may have heard something called DevOps, right? As you make these things, as these things come into the mainstreams in software development, we have something called DevOps. And as machine learning comes into the mainstream, we have MLOps pipeline. So there is something like that. Built-in algorithms, I'm not sure why it says no for Watson, but yeah. Okay, so I think by built-in algorithms, this comparison says built-in algorithms independent of this, what is at the bottom, right? And so in a way, you don't need to reinvent the wheel. So most of them use some, if you look at Azure, it uses scikit-learn, right? And Google also allows you to use scikit-learn. Watson also, I think SageMaker also allows you, though it's not listed here. Most of what is listed are the deep learning frameworks like TensorFlow, PyTorch, Caffe, and so on. And there is one algorithm that came very close to being what is called the free lunch, to violating the free lunch theorem, and that's XGBoost. And so Google has also integrated, Google and Watson integrate XGBoost. And so today, I mean, actually anything that has a backend support for Python, and usually support for Python is in the form of Jupyter notebooks, can obviously use any of these, including scikit-learn and XGBoost and so on. Can you raise your hands if you have used a Jupyter notebook, IPython notebook? Can you raise your hand? Okay, so maybe half the class has used IPython notebooks. Yeah, so it basically is an easy way to run. Yeah, more and more people have raised their hands. So, okay, almost everyone, right? Okay, you can lower your hands. Yeah. So, so if you have support for Jupyter notebooks, then you know that you can kind of load any of these libraries. And so this built-in algorithm means their own implementations. That is, these platforms' own implementations, but most common they use standard libraries like scikit-learn and TensorFlow. Right. So obviously, there's no point kind of trying to cover all these things. So we are just going to use. I initially wanted to use Azure ML because you already have background of Power BI, but then I had to make a tough choice there, right? All of these provide a free account. And so I assume that many of you have used either Azure or Google free accounts, and they are, though they give $200 or $300 worth, they also have a time bar, right? So 2 or 3 months. And so then after that, so some of you may have already used that up. And I know then what you do is you kind of create another account and try to do things. And I'm not sure how kindly they look into that. So I'm going to use Amazon, right? One reason is that if you use it carefully, and by carefully, in the last slide, I will put a red notice. If you use it carefully, you can use it for 12 months, an entire year free. Okay. So when I said other, I think you can try to search, are there any free analytics, cloud analytics platforms? And generally the answers are a little disappointing. Probably the closest is Google's Colab, which allows you to run Jupyter notebooks, IPython notebooks for up to 12 hours, and then they stop it and clear it, right? Yeah. So, but the principles, and that's what matters. So let's say we look at Amazon, but those principles should carry over to the Microsoft, Google, or IBM cloud. Right. So this is the Amazon ecosystem, and it's all of these are very big. So once you go into any of these, and Amazon is the most mature one, so it's quite big. So obviously we are not going to look at the whole ecosystem. I have a diagram that kind of gives you an idea of how vast this is, but we are going to look. I mean, the primary three things you need for a cloud ecosystem is compute, right? And sorry, this should be cloud. It's a typo, right? So most people will think cloud is the second one, the storage. And we will see Amazon has something called the simple storage service, right? Which is, because it has 3 S's, it's called S3. And then it has a more complex elastic file system. Amazon started using this word elastic to show that you can, on demand, increase and decrease. A very, very powerful concept, right? So that you don't pay, right? One of the things, so we have one AND PC, right? So why don't we buy 10 AND PCs? Yeah, we can. And then we have to maintain 10 of them every time a hard disk goes down or CPU, something happens, we've got to, maintain all of them, even though only 1 or 2 are used, right? So this idea of elastic is that you can provision. Provision is a word used for deploying, right? Only what you need, right? Not so it's not fixed. The amount of storage is not fixed. So that's a complicated thing to implement. And of course, we are not worried about how exactly they implement these things. And we are not going to use it. So we are going to use S3, which is the simple storage service from Amazon. The second thing is, of course, the cloud compute, right? Which is about virtual machines, right? And Amazon calls it elastic cloud compute. And so they again use this. So since there are 2 C's, elastic cloud compute, they say instead of ECC, EC2. It's not the second version, and this is not the third version, right? This is short for ECC is EC2, and short for SSS is SSS3. Sorry. So these are scalable virtual machines, and I think all of you are familiar with virtual machines because in the first year you would have had to run them on your computer. Right now, the nice thing is that they give a nice graphical user interface to provision virtual machines. Again, provision means to run or to deploy, right? And of course, each of these things is charged for, right? But charged in terms of accounted for. So when you run a job for a long time, it will debit some number of US cents. And then when it comes to the limit, then only you have to pay. So first year, as I said, I can't remember the amount they give, but if you are careful, you can run it for the whole year. And that's why I select this, so that not using it will not cause a problem like in the others, where if you don't use it for 2 months or 3 months, then you've lost it. Right? It also has a more complex cloud compute called Lambda, right? And this is known as serverless computing. Obviously, you can't do computing without servers. But what it means is that it will, on demand, provision or deploy a virtual machine, get it up and running, run your system, and so on, right, on demand. So again, it's a complex idea, and we are not going to, so in each of these, this second bullet, we are not going to really talk about or use. And then just for completeness, again, we are not going to use this, right? But for completeness in terms of this course, Amazon has RDS service, which is their relational database, DynamoDB, which is their NoSQL database, and Redshift, which is their data warehousing service, right? These, just for completeness, we are not going to use any of that. Another reason for talking about this ecosystem is because you probably already talked a bit about the Microsoft ecosystem, and some of you have accessed or used the Google's Colab, which is not, which is fairly transparent, so you can't really see the ecosystem in that. Or some of you may have used GCP, their cloud platform. Right, there are other services that Amazon provides, like networking, elastic load balancing, and other powerful ideas. So, if you really scale up, like eBay or Amazon itself, or any of these online places which has to increase in capacity on the fly, right? It's a little like how supermarkets may have, let's say, 8 counters, but only 3 are working. And then as they see the queues lengthening, they put another person, right? And open another counter and so on. So it's a bit like that, elastic load balancing. Auto scaling, related to that, all these are about this idea of scaling up and down. IAM, we'll talk about a little about IAM, which is their identity and access management. And if you, I'm not sure, yeah, some of you who may have already used access management if you are trying to access any of the social media like Twitter or Facebook, right? You should be familiar with this access management. Right, so these are actually their services. They call it their service domain. So the first three are what we talked about just now: compute, storage, and database. But they have a whole lot of others, and there are some that are a little confusing because you can see here analytics and machine learning, right? So here analytics is more like BI area, and machine learning is more like BA area. And then mobile, AR and VR and so on. So obviously no single person will use all these, but some idea of these first two are needed for anyone using any of these others. Some may say the first three. Okay, so we are looking at only the first, well, some of these, right? The first one is Elastic Compute Cloud, what it is and what it does. Very briefly, a single slide or two slides. The IAM service, why it is needed and how it does it, right? A very brief thing. But our main focus is on how to do ML using the Amazon service for this is called SageMaker. Right. So the compute service, this is Elastic Compute Cloud. So a lot of you answered, okay, we don't have the required hardware resources. So this is a solution to that, right? So that at least you can, hand off your job to a remote server and then use your computer for what you want to do. In addition, it is easily scalable, both up and down, right? And that's where this term elastic was coined by Amazon. That allows you to only pay for what is used, and because if you can scale up and down, if you think about it, a typical use case for I don't know, let's talk about a communication company like Dialog or SLT, where you have month-end processing, right? Which is a huge load, but rest of the month is fairly stable. So you can scale up your cloud requirement during the whatever 1 day, 2 days, 3 days, where you need to do that processing, and then scale it down for the rest of the month. Well, have complete control in the sense that any virtual machine that you set up and run, so this have complete control is a double-edged sword, right? You have complete control. That means you start a service and then you have to shut it down, right? Now, one of the big things with this is that because everything is done with a single click, right? If you actually set up your virtual machine, you know that, okay, and it's using your computer, and so you remember obviously shut down. But on the cloud, since it's just a matter of clicking something and you don't really feel that there's a virtual machine running there for you, you tend to kind of forget to shut it down. And the problem with that is then it is charged, right? Charged against your account. These are in US cents, but you can imagine you don't shut it down and you come the next morning and you think, oh, I didn't use this, but I have debit. Maybe $1.50 or something, but why was that? Okay, that's because 12 hours passed since I kind of used it. Highly secure. Yeah, so this is where a lot of debate happens, right? Should we have our, data on the cloud? It's a good debate, right? And I don't want you to kind of take any side, right? That it is highly secure, so it's quite okay. But you can see from what the companies are doing, right? The companies are also very worried about security, and yet they seem to use all these cloud services. Governments are a bit more cautious, partly because they feel that most of these are based under the US jurisdiction. So if the US government wants, they can demand, whether it's Amazon or Google or Microsoft not obviously they are the scale are such that they can't say give us all the records. But let's say if they know, okay, Ram Kumar, he has been up to some mischief, right? We want his account details, right? And what he's been doing. Or his company, let's say he has a company. And so there is a fear that they will have to give it. Now, companies like Apple have fought against that, but we all know what happened to someone like Julian Assange, right, of WikiLeaks. They not only stopped his online accounts, they also stopped his Visa and MasterCard and everything. So it's not that it's impossible, but it's highly unlikely that the US government will want to do. Any other government wanting to do this, of course, will have to hack. And that's not out of the question for Russian hackers or Chinese hackers, so that's also possible. But obviously, it's more secure than your own server, right? So we have servers, right? Our web server or DNS server and all that. We try to use as much security as possible, but it's much easier to hack into our servers than to any of these cloud providers. And of course, the last one can access anywhere in the world. Niroshanan was saying, collaborative work. So that's one aspect of this collaborative work when 2 or 3 are working on a project. And that's the reality when you go into the industry, right? You don't work alone. And the other thing is, of course, you have your entire environment wherever you are. Some of you are going to obviously go overseas, and it'll be great, that you have your exact environment that you used available, even if you change your computer. Right, I'm going to go through this fairly quickly because I realize I'm losing time. Right, and so I want all of us who don't have AWS accounts to create them in the hands-on session, and then to set up your cloud compute instance, which means basically your virtual machine. Or in complicated situations, it will be a cluster. We are not going to set up a cluster. We are only going to use a single virtual machine. So some decisions like choosing your Amazon machine image. I think you are used to the idea of machine images, right? So when you use VirtualBox in your first year, I assume that you loaded machine images. ISO images are the most common standard, International Standards Organization based standard, ISO. That's the most common, and most virtual machine platforms like VMware, VirtualBox, and so on support that. And of course, VirtualBox has its own format, and VMware has its own format, and so on. But ISO is like a standard, and that bundles as you have seen, the operating system, any kind of software, and permissions and everything. So when you loaded your, I think we used Ubuntu in the first year, Ubuntu image. It has the OS, which is GNU Linux, right? It has various software like LibreOffice and Firefox and things like that. It has volumes are the hardware, right? So it will say, I need volume for the system, volume for the users, and volume for the swap or something, right? And then permission, it's permission. So when you're working on the machine, you will set up different, you will write your scripts and do stuff and set up permissions. If you remember on that, it was a nice simple model of permissions for you, permissions for your group, and permissions for the rest of the world. And in EC2, we have predefined images, custom images. These are the two primary things. So predefined images are, Amazon has created like templates. So you just take the template and run, which is what we are going to do, or you can take the template and modify. Let's say you increase the RAM. You say, okay, this is the template, the one with the 4 cores, and so on, but I'm going to increase the RAM from 8 GB to 16 or whatever. And then you can, without using a template, you can, specify each of those, right? How much RAM, how many cores, how much disk, and everything, right? And so there is a thing called the Machine Image Marketplace in Amazon, where people have done that. In fact, if you create one, that also will go to the marketplace, I think by default. And so someone else can use it. Now, naming these has become a bit of a challenge, right? Because the namespace is shared among global users. And then there are kind of 5 families or 5 types of these so-called images, right? Compute optimized images. So these are the things where the primary focus is on processing power. So for analytics or machine learning, you can imagine this is one of the important things, right? Of course, if you're going to do some complex analytics, not the kind of thing we are going to do in a hands-on. Memory optimized, right? So this is where you have lots of in-memory operations, right? So the cache is really important for that kind of thing. GPU optimized, right? For gaming or actually something else. So with gaming, you have a lot of concurrent processing, right? And so even in something like deep learning, we have heavy concurrent processing requirements. Storage optimized, right? When you have, if your thing is based on a lot of database, data warehouse kind of applications. And then finally, general purpose. So everything is balanced. And that's the kind of thing we are going to use actually, because we are not really doing really heavy compute processing or GPU processing. Storage, so we have to, and there is a temporary storage where, as you know, that almost anything requires temporary files to be stored. And so in Amazon, it's called ephemeral storage, that you don't even know that it's happening, right? It's in the background and it's deleted, right? It's temporary. Amazon Elastic Block, so this is paid and it's permanently there. So companies basically use this. But the last one, simple storage service, is what we are going to use. And there is 30 GB of that free. You can define whether it's SSD or magnetic. These two we are not going to talk about. If you become if you and your company. So first one is if you become a regular user, then you want to be able to identify your machine instances conveniently. So you can have tags like, it's a little similar to what you do with Anaconda when you set up multiple environments. Right? But here it is not just the Python environment, but the entire compute environment with the memory, storage, cores, and everything. And then security. So this is if you join a company that uses this, then you want to be able to also set up groups and things like that. Right. So we are mainly going to use this S3. S3 uses this notion of bucket, right? And these S3 buckets you can purchase by paying monthly or paying for what you use. And the second thing is what we are going to do. Usually when you pay for what you use, the rate is higher, right? Because if you're a monthly user, they like it, right? So they will reduce the rate. But still for occasional users, the second one is the preferred way. And so you can see here we have on the one hand our VMs and the other hand our storage, the EC2 and the S3. And so we need to synchronize, right, our S3 and EC2 because these are two completely different services on Amazon. So you set up your instance and then you say, okay, but I'm going to store my stuff on S3, right? And not in your virtual machine because your virtual machine will you're going to stop it, right? Very important. You have to stop it, otherwise you will lose your credit. Right. And just before we get into the ML part, so IAM service is the identity and access management. You will realize that the millions of users and billions of resources. Resources are like your instances, your databases, your files, your code, and so it requires a fairly robust access management service, right? I'm going to skip these sub-bullets, right? Hopefully they are self-explanatory, they are sentences rather than bullets, so you can read them and you will get an idea about how identity and access management doesn't only mean the user side, it also means the resource side, right? So IAM policies, right? For let's say this is an example. I may have a policy for an IAM user to access a particular S3 bucket. Right? It will say who can access, right? Who are the users? So that's where this idea of group comes in, right? We are not going to deal with that because we are going to use our own personal machine, right? So we will have like super user access to all our things that we create. Actually, we can allow anyone to access, but it doesn't matter because anyone who has access to our instance, and that is only us. What actions that user can take, right? Which resources the user can access and when they can. You can even say when they can access them. Right. So to deal with that, it defines what are called IAM roles, which we are going to set up in our hands-on. A set of permissions that define what actions are allowed and denied. Right? By default, IAM denies everything, right? So you have to set up an IAM role that allows even you to access your different resources. So this is IAM role is similar to like user roles, but the roles can be individuals or a service. Okay, so let's move on to main part, which is SageMaker. Right, this is Amazon's machine learning platform. In Microsoft, it is Azure ML. In Google, it is now called Vertex AI. And in IBM, it's called Watson Studio. Right, so these are some of the advantages over non-cloud ML environments. So non-cloud ML environments are everything that you have done up to now, including scikit-learn that you used, TensorFlow or Keras if you have used them. Right, so these are the advantages. This creates, manages, compute instances with the least amount of time. So some of you had to use a virtual machine to do some of these things because on Windows it didn't work very well or something, right? So you know how time consuming that is. So this cloud ML environment makes it just a click of a button to run an instance. Automatically creates, deploys, and trains models, right, using your data files, right? So these are the advantage of pipelining. Reduces the cost of building machine learning models because you see that one of the things, and that's a really important thing that you may have encountered, is mismatch of library versions, right? So when you use scikit-learn, you found that the pandas or I don't know, NumPy version was out of sync. And that's why you use something like Anaconda, which tries to do a bit of that, right? In these cloud platforms, they are much more seamless, right? So you don't really see all the incompatibilities, right? They are all handled by the provider. Reduces time required for data labeling. We are not really going to do data labeling, right? But that's up to you if you want to do that. Some intelligent data labeling services. And then, of course, it helps storing all your components and all your pipelines in one place. And it highly scalable, right? And therefore trains faster. Some people have compared, for instance, their Google Colab with our Ant PC. Just the Colab with the Ant PC will probably not do it, but Colab with GPU, though the Ant PC has 4 GPUs, I think many libraries use only one. So the complete workflow, which you by now are familiar with, build. Now here build encapsulates, all the things like data collection, data, wrangling and cleaning and everything, all the way up to building a model. And then test and tune, right, which we normally don't pay a lot of attention to, is a major thing in when it comes to kind of ML ops, at the enterprise level. This becomes really, really crucial, right? So many people, they build a model and the first model that comes out is fairly decent, so they stop and declare success, right? But test and tune is a separate process here. And the last one is almost never done in a typical academic programs, because once we know how well our algorithm works in the test data, we assume we can use it, right? But we never use it. Deploying is actually quite a challenge, a big challenge, right? And so let's quickly try to, what are we doing for time? 60, right? Yes, we should be able to finish in 90. Right. So this pipeline you are already familiar with. We did it with, some of you have done it with scikit-learn or Weka. And in this course, the first part, we did it with RapidMiner, right? So model building provides more than 15 widely used algorithms now. This number keeps changing, right? As more and more algorithms are included. I will go to this link at the end of this course, in this session. And it gives us the ability to select the required server type for our. So everything in SageMaker, or what we are going to do in SageMaker today, uses a notebook, right? A Jupyter notebook or IPython notebook, right? And so an IPython notebook, unlike in Colab, so if you can picture what happens in Colab is that it provisions a VM and runs a notebook, right? The only way you can interact with your VM is through the Colab notebook, right? Here here also for SageMaker, we use a notebook, right, to access our ML algorithms. But of course, we have to define our VM, and so we can also use our VM for other things, of course, right? So these two steps are different in SageMaker or Amazon compared to in a product, in a service like Colab, where both are bundled together, which is the strength also of Colab, but it is less flexible, of course. Then a user can write code for creating and training models using that notebook instance, and that's why the notebook framework is really, really important. Then you can choose and optimize necessary algorithm, right? There are some examples here, but of course you know many more algorithms. And allows customizing these machine learning instances using the notebook, right? So this is the model building part. Then testing and tuning automatically. SageMaker is able to use sensible combinations of hyperparameters for tuning. Now, this is good and bad, right? It's bad if you don't know what to do, right? If you don't know what parameter tuning is, you don't know. Or it also is bad if you treat it as a black box, right? You know. Okay, so it's something like scikit-learn. You can do this parameter tuning using something called grid search. Grid search will allow you to go through, do what is called parameter sweeping. It goes through parameter combinations in an exhaustive way. And that's very often not practical. So you may have some kind of randomized parameter sweeping, right? So you can imagine that means you are not able to actually find the best parameters, but exhaustively. I mean, these models, it's a bit like running the same model over and over again for every parameter combination. And obviously, you know that that's going to be too expensive, right? Because particularly in deep learning models, if you have used TensorFlow or Keras, you get the model summary gives you the number of parameters, and typically it's in hundreds of thousands. So here, SageMaker uses some sensible combinations. And so it makes sense to ask, what are sensible combinations? Right? It stores the data on S3 and the models in what is called ECR. These are Docker containers, right? I'm not sure whether you have had any session on Docker, right? So it's a lightweight, you can think of virtual machines as containers, right? But the virtual machines are containers that are heavy, that have storage resources, memory resources, all those things, right? Whereas lightweight containers like Docker don't have that, and of course the operating system, right? Whereas Docker will use your host operating system and not, have a operating system loaded on it. So obviously, explanation of Docker is outside the scope of this lecture, but consider it as a packaged kind of a way of packaging, for our purposes, way of packaging a machine learning models and reusing them. So if you want, and then if you want to predict, let's say a few data points, a few new data points, right? At a time, then we can use their own hosting service. But if you want to predict an entire data set, then we have to use what is called a batch transform. We will not use this. We are going to use something different, but we will see how we do this in the hands-on. So you build a model, test and tune, and then you deploy. This is the step that normally we don't talk about in academic courses, right? But it's really, really crucial if you're in a production environment. So this is where your models, once you are happy with the accuracies, you deploy them to publicly accessible, what are called endpoints, right? So that you can give a URL to someone, right? You can imagine how difficult it is. So you consider you're now running your VirtualBox instance, right? And you have created your model. Now you want to allow people to use the model. Okay, what do you have to do? Obviously, you would have to run a web server on your virtual machine, right? And give it access. And that's also not easy because within the university or in your home, we are using private IP addresses, right? So you can't really expose your web server to the outside world. So deploying is fairly complex, right? And yet it's all transparent. We don't see that, right? And that's why these things, you may wonder why this thing is taking time when you do your hands-on. That's why I say you still need to have your 2-hour session this week, right? It won't take 2 hours, right? But since you want to experiment with things, it's good to have the 2-hour session. And this can be used to, of course, evaluate and monitor your deployment. And one of the important things in ML Ops is after that to monitor, because you may find that your data keeps changing and the model is no longer as accurate as you predicted, and so you will want to then train a model again. Right. So this is the kind of the workflow for training an ML model. They are trained by starting what is called a training job, and the training job consists of these things: an S3 bucket, right, within the computing. So that means we can, in our virtual machine, create an S3 bucket. But of course, it's not persistent because we are going to shut down our virtual machine after we use, right? But this S3 bucket will have the URL of the this compute instance or this virtual machine will have the S3 bucket URL where the training data is stored, right? And then the ML instance, which is your virtual machine, right? That specified what kind of compute resources and what kind of machine learning frameworks you're going to use, this scikit-learn or TensorFlow or whatever. And then we also have another S3 bucket outside our VM, right, where the output will be stored. So even once we shut down our VM, we can still have access to our output data. And then where the code image, right, our code itself, where does our code sit? It's in this Docker container inside the registry, ECR, right, where that particular code is saved. Then where the input data is fetched from this S3 bucket inside the instance, then once the training job builds the model, it launches the VM. It then trains the model with the training code and the data set, training code from the ECR and the data set from the S3 bucket. And sorry, this says interference. This should be inference code. Consists of multiple. This is not very important. So this ECR helps us to save, monitor, and deploy container. So once you have now saved this, once you have a successful model, you save it, and then you deploy it, and then you can monitor it, right? How it's performing using this ECR, the container registry, right? So we are going into our hands-on. Just before doing that, just to say the common ways in which we validate the models, right? Have some held out data or testing data, sometimes called the validation data, right? And this happens when we split the data set into train and test sets or train and validation sets, right? So this is what we are most used to, right? And this is the only way we normally do things. But you will realize that often we don't have the luxury of keeping aside some test data, so we may have to do cross-validation. And I think I have also explained this enough, and before me, other people have done it. So we know the use case for these two. There are two other use cases that SageMaker supports: offline testing, right? So you just send request to your model for some, some data set you have, right? And then, so it's the equivalent of some of you are doing, for your projects. After you build everything, you want to see how good it is going to be in the wild, not just with my test data. How is it? So you collect some more data from the wild or the internet online or whatever and try. So that's the case for offline testing. And the last one is something that we don't think of, but if you think about it, whether you use IMDb for movie recommendations or you use eBay for buying stuff, all of them have to deal with live data, right? So if you want to test the accuracies of live data, then Amazon provides a way for that also. So here's a diagram. There's some small arrow problems in this diagram, right? This is the S3 bucket that is created within our instance. So here's the instance, right? The VM that we create. And the VM we create, other than it has, the memory and disk space and everything, cores and so on. In addition, it has our training code, which it gets from the ECR, right? It stores our model as an image, right? We call it an inference code image. So once this VM is shut down, we still have access to the results. Right. So this the hands-on tutorial, I'm just going to start you off on, but what I want you to do is linked here. So the part I want you to do now is to sign up. Right? Luckily, unlike the case of accessing some of these APIs like for Twitter and Facebook, you don't have to wait. Right? It is done instantly. And this is the most important thing here. It allows credit, but more importantly, lasts up to 1 year if you manage your credit properly. And we are going to do in the hands-on is we are going to use Amazon's tutorial, that is the link, what is linked here. It creates a SageMaker notebook instance. It prepares the data, trains the model to learn from the data, deploys the model, and evaluates model performance, right? The 5 main steps. But I want you, in addition, to try this, see what the data looks like. I mean, I've always said that's absolutely crucial. Don't treat these as black boxes. And since we are going to use the Jupyter Notebook to do all this, you already should be able to figure out how to look at the data. And secondly, I want you to try some other machine learning algorithms. I'll show this link in a moment. But probably the most important thing here is this one, right? Shut down your instances before leaving, right? So I'm not saying before logging out, because sometimes you may not even log out because it won't seem as if you're running a virtual machine, right? Because it's all on a web interface, right? So you don't really see it. You have a little bit of experience with this when you used Jupyter Notebooks on your computer. You will realize that it just runs on a particular port, and so it opens a web page, right? If you don't shut it down, it'll keep running. Of course, since it's on your machine, there's no cost. There is a cost, and that is that it's eating up some resources, right? So you can go back and see whether it's running and kill it or something. In here, you won't know at all that it's running because you will, use a different tab in your browser, and you won't even know that this thing is still running. And if you run it overnight, it's not going to be, a few US cents. But let's say you forget about this and come back to this after your exams, which is going to be like April or something, right? And you realize, oh my gosh, my server has been running for 3 months. I'm not quite sure what the cost would be, but it's a waste of resources. Okay, so let me share what that link points to. It's a nice little there is a site called Simply Learn. I'm not sure whether you have. So that this leads you to that, right? And so it says 10 top machine algorithms for beginners and machine learning. And so these are the things it explains: linear regression, logistic regression, decision tree, SVM, Naive Bayes, KNN, K-means, random forest, dimensionality reduction, gradient boosting. Well, boosting algorithms. And it talks about each of these, right? So it's a nice thing to read, but I have asked you to try some other algorithms. Can you unmute and let me know? Can you try linear regression on this particular task? Okay, I haven't told you the task. So let's first go to the Amazon page. The tutorial. So here's the tutorial: build, train, and deploy a machine learning model with SageMaker. These are those 5 steps. And this is what you do before you begin, right? So even as I'm talking, you can go and do this. Sign up for AWS if you don't have an account. Otherwise, log into your account and you can check how much balance you have, right? So these are the 5 steps. Create a SageMaker notebook, right? By the way, it makes you figure out a region, a preferred region. This is for latency issues. For Sri Lanka, it doesn't really matter because we don't have a region in the country. And sometimes even if there is a region in India, it may be less latency for accessing the US one than the Indian one. So, and in the US, you have the West, East, and things like that. It doesn't really make a huge difference, right? Because it's not easy to find out which of their server farms is more free. It's really not possible, right? And so you do this by signing into this SageMaker console. All these are linked, so it should be very easy. And then in that interface, you have a thing called the notebook interface, right? Notebook instance. And so this will ask you to create a VM, right? and you have to give a name for that VM. Now, this is a bit funny because what you are used to in the first year was that you don't give a name, right? Well, you can give a name, but most of you didn't. You just use the default name, which was Ubuntu or Linux Mint or something like that. Right here, you have to give a name. So you may wonder what the name is. Of course, you can use the default name here given, which is the SageMaker tutorial, or you can give it any other name, right? But a name that will help you to remember this one. So you can always call my first, that's the normal thing we do, my first AWS ML job or something like that. But the most critical thing here is the notebook instance type. We say notebook instance, but actually it's the VM type, right? You can, the drop down will show you lots and lots of types, right? This is the default for machine learning, right? So I leave it as an exercise for you to know what this machine, a virtual machine template has, how much RAM, how many cores, that kind of stuff. I want you to try to figure out, right? And these virtual machine specifications are available on their site. By the way, everything that we are doing now with with AWS, there will be a parallel with Microsoft Azure, and there will be a parallel with GCP, there will be a parallel with IBM Cloud, right? You have to select a particular instance type, and in the instance type, this is medium, so I think there should be one called light or something like that, small or something, right? Which will have 4 GB RAM or maybe 2 GB RAM or something like that, right? So you can see this is you can keep it at the default, which is given in this tutorial. So elastic inference, we are not going to use it because we are not going to require bigger and smaller amounts, right? So we leave most of the others at their defaults, right? And then there is this IAM role, right? And since you won't have already a created IAM role, unless if you have one, you can use it, right? If you don't have, then you have to create an IAM role for this resource, which is the S3 bucket, right? You can specify, just go with the tutorial with the default names. Later, you can try to change those things, right? Okay, what kind of access? So here we are saying to give root access because only we are going to use this, right? Obviously, if other people are going to use this, we are not going to give root access. Once you fill all those things and you just click here, create notebook instance, it will take some time, right? It will say, so you can imagine what it's doing, right? It is loading an image, right? Creating a virtual machine with the required software for machine learning, right? Which comes with this this particular instance called MLT2 medium, right? And it then has to boot it and come to the ready. So for that, it will say pending for a while until it says it changes to this, right? So the status from pending, it will come to in service, right? So anything that is in service means there is a dedicated virtual machine for you running, right? And so that, so you can always come to this console and see what are the things that are running and shut them down at the end. So here now we are going to actually use this. You can, I think you probably are more familiar with Jupyter Notebook, so you use this. If you're familiar with Jupyter Lab, which is a whole environment, you can use that. But let's go with Jupyter Notebook, and you're going to write a new notebook. So under new, you have lots of different types of environments, right? You have R environments and Python environments, plus Spark, which is for distributed computing, right? MXNet and stuff like that, TensorFlow. So dedicated things with TensorFlow or with MXNet or things like that. But we don't want any of those. We are using. So even with this normal Conda Python 3, you can of course import TensorFlow or MXNet or anything like that. So we are going to use the plain vanilla Python 3. And then we are going to write our code, right? And I don't want you to just write the code, right? What is this importing? Hopefully some of these you will recognize. Boto 3 you won't recognize. So if you think about it, that's the equivalent of how we access our data, right? We normally use IO to access files on our data system, right? Similarly, to access S3 files, we use this Boto 3, right? Regular expression, you should have used, I guess, sys. You may have used math, maybe not JSON. I'm not sure that you've used OS. I mean, these are all standard ones. URL request to access URLs. SageMaker is the only new thing here, really, and Boto 3, right? And then from SageMaker, we get this get execution role. The others should be common to you: NumPy, Pandas, Matplotlib. And then there are some additional things. Time is a standard thing. And then we have to define IAM role. And we are going to use the XGBoost algorithm, right? Now, the documentation here is not great, right? I will also try to find a slightly better documentation. Then the region name, right? That here it is getting the region name, right? And which you have defined at the top there. And then it sets the XGBoost container, which is the Docker container where your code will run. Okay, so there is a exception handler here, right, to catch exceptions with handling your S3 bucket from within the code, and also whether it had a problem with loading that data, right? And then we do some standard things like shuffle the data and split into training and testing and train on 70% and so on. Right? You need to scroll this way to see some of that, right? So you can type this, or you can simply copy like this and paste, right? But don't just copy paste, and run. You should. So each of these cells you copy, paste into your notebook, and then execute that cell to make sure that it's running. Then step 3 is to train the ML model. Right? It is giving the training data and labels, and where the S3 bucket is for input. And then it is using, okay, so this is SageMaker.estimator. Estimator is, we point to that XGBoost container that we created. And then there are some hyperparameters here, right, which we are setting. Right. You can change those and see what happens. The objective function, you can change that, and so on. And those are for later, right? First get it working and then try to change and see what happens. And finally, to train the model, as usual, we do xgb.fit. In scikit-learn and TensorFlow and all, Keras and everything, you would have used the fit function to actually train the model, right? And so the XGBoost library also has the same thing. I'm not sure whether you have used XGBoost in Python, but it's the same thing. So you can use XGBoost in Python also. It's not included in scikit-learn, right? And the final step is normally not done. Okay, we don't worry about this usually, right? But it's an important step if you want to give others access to your code, right? So it clearly distinguishes your model development and model deployment. So we call XGB deploy and give some parameters. And here we are saying to create an instance which is not the medium one, but the large one. Just check what this ml.m4.xlarge is, the specification of that. It's good to know, right? And then we can send some test data and look at the predicted results. Here we are only doing the size of the predicted table, right? So by the way, since this is a normal IPython notebook, please go and type the name of the variables to inspect the data, right, before doing all this. And finally, the model performance, right? We run the code and we ask it to print the confusion matrix, which we are manually printing, right? We are not calling any library. We are manually working out true negatives over true negative plus false negatives into 100 and so on. Right? We are actually printing. What should happen is you will get something like this. Right? We are not using a library function call for that. Right, so that's it. And I want you to change the hyperparameters of the XGBoost and see whether you can get better results. Right? This is already having a fairly good performance, but can you improve it? The most important step in terms of keeping your account for a year is this cleanup, right? The first thing here is to delete your endpoint, right? Endpoint is where the way you expose your machine learning model, and then deleting the training artifacts and the S3 bucket, right? And then deleting your SageMaker notebook, right? Now here we say SageMaker notebook, but actually that's a VM, right? So you need to, what you do is you go back and you see it like this, right? In service. So you've got to select it here. So you've got to select it here, and from the action say stop, right? So good luck with your first cloud ML, right? So the cost of this entire, so this is to give some idea, the cost of this running this entire lab, hands-on lab, is less than $1. Actually, it's sometimes it may not even show, it may say 0, right? Because this happens so fast, okay? Because the data set size, as you would have noticed if you were carefully looking, is 28,000 records, right? So for the training and 12,000 for the testing, right? And it has 61 attributes. I hope you know this shape method, right? You can, your data, if your data is in a pandas frame, you can just do dot shape and it will give some information. But I want you to also look at the data, right? Print some of the data out and see. Right, I've gone over my time. Apologies for that. But I do hope that even if you don't have, even if you're busy with your project, right? Try to see the bigger picture, right? If you join any company, it's likely that they will not expect you to use Anaconda and run things on your own computer, but they will expect you to run it on one of these. So it may not be Amazon, right? It may be GCP or it may be Azure. No problem. The ideas, the concepts are the same. You need to run instances. You need to have places where you store your data and your results. And some of that may be databases or data warehouses. And you need to be able to not just develop and test and tune, but you should also be able to deploy, right? So the MLOps thing goes on even beyond deploying up to actually monitoring, right? And have a good weekend.